Fast and the Furious Exposed, a family favorite movie filled with lies. Today we will be exposing the franchise and seeing how the directors neglect to find the true physics behind their movie scenes. Our first topic of business, momentum. We will be analyzing the scene in Fast 5 when Dom jumps across a bridge to catch his beloved girlfriend Letty. To start off, we will be using the equation for momentum, in which momentum equals the mass times velocity, and the initial momentum equals the final momentum. Initially, we have Dom's mass plus the mass of the car multiplied by the car's velocity. Dom is traveling at the same speed as the car, and the car is matching the speed of the tank, which is traveling at 60 miles per hour. This is double what an average tank would travel at. As you can see, the movie is already breaking the laws of physics. We will set that all equal to for the final momentum, in which Dom is no longer moving, in which the car is no longer moving. It is solely Dom flying through the air. Dom weighs approximately 225 pounds, which is 102 kilograms, and the car is calculated to weigh 1,687 kilograms. We will add that all together and multiply it by the velocity, and put that all over 102 kilograms to calculate for Dom's final velocity. We find out that Dom should have been traveling at the speed of 470 meters per second. Now, to calculate Letty's velocity, we will use the same process as before, but we will replace Dom with Letty and the car with the tank. Letty weighs 120 pounds, approximately 54 kilograms. The weight on an average tank is 68 metric tons, and when converted to kilograms, we get that the tank she is traveling on is approximately 61,688 kilograms. Dom was matching the speed of the tank, so we will keep the initial velocities the same, and then we will put that all over her 54 kilograms, and we get that Letty is traveling at the speed of 30,642 meters per second. Basically, they would be like Miss Keisha, dead. Moving on to another scene in the second movie of the Fast and the Furious franchise, Brian attempts to fly his car into a boat that is 23 meters away from port. From the beginning of the clip, we can see that Brian is traveling at the speed of 120 meters per second, or 120 miles per hour, or 54 meters per second. By looking at the photo captured, we can see that Brian is traveling at approximately 5 times the length of his car. So multiplying 4.78 meters by 5, we get that the distance he traveled in the horizontal direction was 23.9 meters. We will use these numbers to calculate for the angle needed to jump off in order to make it safely into the boat. And the equation for the range of a projectile is the initial velocity squared times 2 times the sine of theta all over gravity. We will use this to find theta, in which theta equals the inverse sine of gravity times the range all over 2 times the initial velocity squared. When we put that all together, we get that the car only needs a ramp with the angle of 2.3 degrees, but from rewatching the clip, we can see that he went on the ramp that was approximately 30 to 45 degrees. Therefore, he wouldn't have made it into the ocean, but would have instead been stranded in the ocean.